So during class on Thursday, a question came up right before the quiz, which I don't think I did a good job of explaining. So I want to take a second shot at it right now. So this was on the discussion on improper constraints. And before we get to the question, let me summarize the steps that we follow to determine if a system or a problem that's given to you is properly constrained or not. So what we said was to check if we have an improper constraint in the system. The first thing that we do, of course, is to draw the free body diagram and mark the reactions. And the reason why we do it is because for a system to be in static equilibrium, all the resistance provided to the applied forces has to come from the reactions. And depending on the reactions or the locations and the directions of the reactions, a system may be properly or improperly constrained. So the second step that we discussed is to check if you have, well, all the steps from here on are checks. So the second step was to check if you had two or fewer reactions. And if that were the case, you would have what we call as partial constraint. Alright, and what this means is that not all the possible movements are restricted. Possible movements are restricted. Which just means that your body, under some force, would experience some movement, which means it's not in static equilibrium. So if it fails the first check, you know you have a partial constraint, which is also one case of improper constraint. And the second or third step, was to test or check if you had three reactions, but are in parallel to each other. And if this were the case, we would have another case of improper constraint. And this just means that the movement in the direction perpendicular to those reactions, which are parallel, is not restrained. So, which means you don't have equilibrium, or static equilibrium. And number 4 was to check if you have three reactions, but it passes set numbers step 2 and 3, but the reactions are concurrent, which means the forces pass through a single point in that plane. And this would mean that you'd still have improper constraint. And the motion or the movement that is allowed in such a condition would be the rotation. So the rotation of the body is not restrained. And why is that? Remember, any reaction to applied forces has to come from these restraints. So if all those reactions together cannot come up with a counteracting moment, you would be allowing some rotation, which means that the moment is not restrained or counteracted, and which would mean you would have some kind of a rotation due to that moment. Some combinations of those reactions should provide a counteracting moment, otherwise you would not be able to restrict that rotation. So having said that, let's get to the question. Now in class, I introduced this system first. Where you have a beam which is pinned on one side and there's a roller on the other, and then there's some force acting on it. And the first step that I did was to draw a free body diagram of the system. So I released the supports and then assign the forces or the reactions that we get. And let me just highlight what the reactions are in red. And after I introduced the system, we went through checking whether this was partially or improperly or fully constrained or properly constrained. And we checked step 2 and realized that there are more than 2 forces or more than 2 reactions. So that passes. And step 3, we also realized that the forces are not parallel. So that passes as well. But we then realize that the forces are not, or they pass through the same point. So if we extrapolate, or if we move the force on the right side along this line, we find that all the forces pass through the same point here. And so they are concurrent. And so this condition does not pass, so we call it as improper constraint. So why is that? Since the reactions are concurrent, in the moment equilibrium equation, these reactions together cannot form a counteracting moment to any applied force or moment. So what I said was that this system is improperly constrained. And then right at the end of the class, I introduced another system, which was a plate restrained by rollers like these, and asked if this was proper or improper constraint. Let me separate these two. So now, again, we drew the free body diagram. Release the reactions. And we know the directions of the reactions, which I'll highlight these red stripes. And then we went on to check the same 3 conditions. So we know that there are more than 2 reactions, so this passes. We found out that the reactions are not parallel to each other, so that condition also passes. And we also found out that the reactions are not concurrent. They don't pass through the same point, which meant this also passed. And hence, I said that this was properly constrained. Now, the question that came up at the end was, what's the difference between these two systems, where this the system on the left allowed the rotation and was improperly constrained, what's preventing the same rotation on the system on the right? Because you still have two rollers, and wouldn't this have the same rotation in this direction? So the reason why these two systems are different is because, of course, if we go systematically, we know that the step 4, in the step 4, system on the right passes and system on the left fails. But intuitively, what we have here is, remember what I said, for any load, if the reactions are able to counteract all the forces in the plane, which is the x force, the y force, and the moment, you have a properly constrained system. So on the left, we have something that can restrain the x direction, or the forces in the x direction, and y direction. But we don't have anything that can provide a counteracting moment. But on the right, we have, let me highlight it with a different color. We have these two reactions that I've highlighted with green that is able to provide a counteracting moment. Now imagine if these two forces were opposite and equal, something like this. This would produce a couple, and you can have a moment or a counteracting moment. If I remember right, in class, I did not explain that whatever force you apply on the system on the right, let it be a force here or a moment here, this system would be able to restrict any movement. And I don't think I mentioned that point, and that point is important. So yeah, I think that's all I have to say about that. So thank you.